So we're going to pick up looking at the linear search. What is the maximum number of items that would have to be examined to find a match in a list with 1,000 items? Well, the answer for that is going to be 1,000 items you'd have to search through. What is the minimum number of items you'd have to be examined to find a match in a list with 1,000 items? Well, if your item that you was looking for was right at the start, then you would be able to see that you find it in one hit straight away. So the answer is 1. And the average number, well, depending where your number is in the list, if you on average ran that 1,000 times, the average times it would take to find the item would be right in the middle of that list, so therefore it would be 500. Total number of items that would have to be examined if there was no match to be search criteria in a list with 1,000 items. Well, it would go through each one, starting here, all the way for 1,000 items to find out that it wasn't there. So it depends on how many items there are. Here's 1,000, therefore your answer will be 1,000. And when we search a list, what is the index of the first item? Here it's iteration number 1, but we call the index 0. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the index is 0. So understanding linear search. If this was our list of data that we're looking for, how many iterations would you need to do in order to find the key of 18, to find the number 18? How many iterations would you have to loop through that process until you find it? So you can put these answers in your ePortfolio. You are doing a linear search of the ordered list, so this time the data is ordered, so from the smallest number to the biggest number. Remember, linear search doesn't have to be. How many iterations would you need to do in order to find the key 13? So how many times would you need to? Little trick question there, see if you remember what has been said. Okay, we're going to move on to another type of search. Now, linear search is great if you've got just a small list and you can look through the information, or your list is not ordered, it's not in any particular order, or you have items like I've said before with colour, or people's names, although they can be ordered alphabetically. You're looking for something that's non-linear. With a binary search, it's much more efficient. It's a quicker way of searching a large list of data. It's quicker than a linear search, but your information does have to be in a ordered structure. Now, it uses a divide and conquer algorithm, so it splits the data, divides it in half to find the information it's looking for. So it does split with if you had 1,000 items, it would look at number 500, and if it's in that ordered list, if it's bigger than 500, it would get rid of everything that's smaller than 500, so it's half the list straight away. And it can only search, I've already said, if the array is already sorted, so if it's in an order. So the way this works, I'll bring up a little bit of information. It's basically how we would look for a word in a dictionary. If we're looking for the word Python, we'd probably open the dictionary about the middle, and the middle letter in the alphabet is an M. So what we've realised, if we find the M, we can then get rid of everything before that M in the dictionary. So we're just left from M to Z. And we know then that we can jump ahead a little bit, and then we can work out if we need to go forward or backwards. And that's exactly how a binary search works. If I was guessing a list of numbers, if I said to somebody guess a number between 0 and 100, and I wanted to be efficient, I would go to the middle number and I would say 50. And if my number that I'm looking for is 80, that's the number I've got in my head, I start at 50 and they say no, it's bigger. And then I'm looking for a number between 50 and 100, so I'd say 75, and they say no, it's bigger. So I'd then say maybe 90 or 92, and they'd say no, it's smaller. So I'd go to 85, and they'd say no, it's smaller. So I'd go to 82, they'd say no, it's smaller. So I'd go to 81, they'd say no, it's smaller. So I'd then say 80. So I've managed to find my item very quickly by halving the data every single time, and that's how a binary search works. Now, the flow diagram for a binary search looks a little bit more complex, because what it's actually doing is splitting the data in half every single time. until it finds the item it's looking for, or until there's no more searches because the item's not in the list. So I'm not too worried about the binary search algorithm. You can have a look at it and see if you can follow that, how a binary search works. And again, the coding for a binary search is a little bit more difficult. Now this is an extension task. If you'd like to have a go at writing a binary search, here's the code. You can pause the video and put the code in and see if you can get that to work. So an example of a binary search, I've already talked one through, and I've got an ordered list. So the numbers go from the smallest number in the list, which is 15, up to the biggest number of 98. And the middle value is 43. Now I'm trying to find the value 50. So I've got number of items, search criteria, looking for the number 50. So let's just check we've got number of items: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I've got 16 items. So I'm looking in the middle, which is item number 8. 1, 2, 3, 4, 5, 6, 7, 8. So that's why I start at 43. So I'm looking for the number 50. I go to the middle item, 43, and what I'm looking for, 50, is bigger than 43. So I can get rid of all of these numbers here. So I'm left with these 48 to 98. So now I've got 1, 2, 3, 4, 5, 6, 7, 8. So I'm looking at halving that. So I'm looking at the fourth item. Remember, I'm looking for number 50. But I go to the fourth item, 64. Now 50 is less than 64, so I can get rid of everything from 64 upwards. So I'm left with 3 items. And again, I'm still looking for 50, so I look for the middle item. And I find my middle item of number 3. So I've managed to find the answer 50 in 3 iterations. Whereas if I was doing a linear search, it would take me a little bit longer. 1, 2, 3, 4, 5, 6, 7, 8. So we can see here that a binary search is much more efficient. It's a quicker way to find an element in a list. So again, we've got an example here of looking for the number 23. We go to the middle item, which is 16. It's bigger than 16, so we can get rid of all of these. And then we look for the next item, which is 56. Again, we can get rid of the 56, 72 and 91. So we're left with 2 items to look for, and if you're in between 2, you go to the left hand side, and there it is. We've got the number 23. So again, that was found in 3 iterations. So the advantages and disadvantages of binary search. The advantage is it uses a divide and conquer algorithm, and therefore it's a more efficient way to find an element, because you're halving the amount each time, each iteration, each way through the operation. So it requires less iterations to search for an array. The downside to a binary search is it has to be an ordered list, and it is harder to code in computing. So you need to explain the advantages and disadvantages of a binary search in your ePortfolio. So thinking about your understanding, which numbers would have to be checked while looking for the search criteria 8? So we'd start with a few questions. You explain what number you go to in your ePortfolio, and then what numbers you're left with, then what number you'd look for until eventually you find the number 8. And if we've got this sorted list here, which ones would you go to find the number 17? So what number would you look at first, then what number, and so on. And if we were looking for number 13 in this list, explain the process that you would go through looking for the number 13. So that will test your understanding of a binary search. I'm looking for that information in an ePortfolio. So again, update your information, add it to your ePortfolio, and submit your work to your teacher.